So this is our air conditioning and refrigeration lab.
This is for research or for teaching.
For both. Most of our labs do both research and teaching. We try to blend the two activities together. The researchers often like to tell the students what they're doing, and the students are always interested to find out what's new and what research has been done. So it works both ways.
Yeah. For example, this ring, what is for?
So this is a bit of a commercial testing work. The manufacturer of this white air conditioning unit. I don't fully understand it, but he's found a way to make it more efficient by extracting some of the energy out of the air that's normally exhausted from the building.
It is about testing an air conditioner.
That's right. Yes, testing an air conditioning unit.
Not
box in the middle.
Not the duct system. Not the air duct system. The air duct.
Air duct.
The air pipe, you know.
The pipes for ducts. That's right. Yeah. So one would be feeding it with, I think, warm, humid air. There's a certain amount that's recycled back again, and then some of that air is pushed out into the lab. And what's pushed out, I'm not sure actually. I'm not sure how it's set up. There's a difference in temperature and humidity in these different lines. Usually with air conditioning, a certain percentage of the flow is recycled within the building, and maybe 10 or 20% is brought in from the outside, and that's conditioned down to the inside conditions.
This research, who think about it, and what is how they can finance this?
It's mostly paid by the company that manufactures this unit. They want some independent testing done. So it would be all paid by the outsourced company.
By company.
But we have one academic who's interested in making air conditioning units more efficient. So he tries to learn something from this, and this may well develop. We may do like some contract research for the company. They might pay us to make it better for them. That often works. Often happens. This rig down here we use for teaching.
For teaching.
Yeah, there's a schematic of the system. And we have a special room just through here where we have a heat source and a humidity source. So it generates hot, humid air that this system takes in. We have a chilled water unit here that supplies this unit with cold water. And that cold water is used to cool the hot supply air and also to lower the humidity.
Yes. It can adjust the temperature and humidity. Yes.
So we measure humidity at this point and also temperature. And have cold water supply pressure and temperature. We measure those parameters at various points along the chain, and we can switch different systems in or out to create to vary the system. Students look at different situations.
Why at this time there is no course, there are no students? Why it's open? It's still why it's still running? But there is no teaching at this time.
Yeah, at this time there's no classes at this time. but this is used every semester for teaching air conditioning and refrigeration
Oh, yeah,
to our
yeah,
students.
yeah,
A lot
yeah.
of our mechanical engineers get jobs in building services, and that's a lot of that is air conditioning and
Oh, yeah,
refrigeration.
yeah,
So it's mechanical engineers, many mechanical engineers are employed designing, building, installing air conditioning systems.
Oh yeah. But the no class at this time. Why it is still running? What is openings for? I mean
When you say still running,
the machine is running here
what you're hearing
now.
at the moment is the one up above.
Oh yeah,
which is normal
it,
laboratory.
not
yeah,
here.
This one's not running at the moment.
Oh yeah. Yeah, I see.
PV panels. Just for introductory subjects, where the students learn about energy conversion. Both photovoltaic, also photothermal. It's just used for one lab for introductory subjects.
Oh wow, it is big the engine
Yes.
testing.
In this lab, we are preparing some engines for some students to use in lab classes, where the students learn about the thermal cycle inside the engine.
And they this assemble the components and the parts and
Yeah, we buy the engine from the company, or sometimes they'll give it to us, and we just use it. We set up on one of these test beds, where, for example, the engine is connected up to a dynamometer. So this puts a load on the engine. Instead of the engine running freely, to properly measure the performance of the engine, it must have a load on it. Like if you imagine a car either accelerating or climbing a hill, there's a load on the engine, and this is like a brake load on the engine. So this is a fairly modern V6. Is it turbocharger? No, it's not turbocharger.
they I mean when there is a class and there is a shop and the student they do about disassemble and assemble the part.
No, they don't know.
They or they just run the engine and
That's right, run the engine
measure
and measure
the
lots of
power,
different things.
the performance.
Yes. Typically we would measure the energy going into the engine in terms of the fuel flow rate, and we know the calorific value of the fuel.
This is the
And we
gasoline.
measure the energy coming out of the engine in terms of torque and speed.
Oh yeah. This is gasoline or the diesel or gasoline engine.
We did have a diesel sitting right here, but that's been replaced with this one. But there's a turbocharger here. At the moment this all looks very messy because it's still under construction. Looking at making small engines more efficient. That's over the back there.
What about the research? There are a lot of research here, or not really much.
Sorry. Is there a lot? In some areas we're doing research, in other areas not. For example, with the small engines over the back there, that's a research project that's just finished. Trying to make small engines, the sort of engines you'd see on lawn mowers, small motorbikes. A lot of those are quite polluting.
That is motorbike.
Or a lawnmower, very small engines. And so that research is, I think it's just finished. I'm not sure on that. But these other engines, this is just for teaching.
Oh wow.
This setup here, We're looking at both powertrain, vehicle powertrain systems, both systems.
Hybrid and
Hybrid car systems.
between the gasoline and electricity.
That's right. Yes. Now, originally this was a gasoline only, with an engine, gearbox, and we had a shaft going through here to a differential that powered these wheels. That original project was set up to measure the torque transients on this gearbox.
Did it the bus, the engine?
No, it's from a large car.
For large car.
Yeah. With a 4-speed automatic.
For a big truck.
No, large car.
Large car.
Yeah. Ford Falcon. With a 4-speed automatic transmission. And this project was mostly focusing on the transmission. Every time it changes gear, you get like a clunk, a torsional transient going down through the powertrain. And we were studying that transient. Now that project is finished, and the current one is with this electric motor and gearbox, very simple gearbox, with a control system. This is contract research, contract testing. We're testing this for an overseas manufacturer. Now,
they do the test and the research in this lab every day.
Most they do. I was down here yesterday. There were a few people here. At the moment, we've got a problem with our cooling water system downstairs. So I think that's why nobody's here at the moment. At the moment, we can't run it. We don't have a cooling system to take away the heat. The motor and the dynamometer down the end, they must be cooled with water.
What is this the red line and connect with to that component, the round shape?
This is the main power lines.
Power line.
Three-phase power going into the three-phase motor.
That is motor.
And the cooling lines, cooling water.
Cooling water. And what about that component?
A gearbox.
Gearbox.
It's a modified vehicle gearbox. So that powers these wheels, which power some flywheels that simulate the inertia of a car. And then the flywheels drive another set of tyres, and down here we have a dynamometer. Another dyno. So this puts a load on the electric motor. And we can control that load. So we can simulate the car climbing a hill, or we can control the load as the motor accelerates.
To take
classes as well, both we have a subject called air pollution, where we simply use this as a source of air pollution, and the students study that air pollution, take some measurements. To measure the carbon dioxide, carbon monoxide. Yeah, carbon monoxide, carbon dioxide, oxides of nitrogen, hydrocarbons, water, all those things we measure in the exhaust line.
I have some question. This is 100% government university.
Yes, it is. We get some income from consulting work and some income from overseas students, but most of our funding comes from the federal government.
What is the popularity or the ranking student they compared to University of Sydney, Macquarie, RMU, Royal Melbourne?
Yeah, RMIT. Across all disciplines, Sydney University, Melbourne University, probably the top two. And we're middle ranked. The actual rank I don't know what it would be. We're sort of middle, not high, not low. In the engineering area, we would be on par with New South Wales University and Sydney University, where each university specialises in different parts of engineering. But out amongst the engineering community, those three universities are rated fairly highly, at least in Sydney.
In the Department of Mechanical Engineering and Faculty of Engineering, there are a lot of PhD studying here.
Yes. And quite a lot of PhDs use these lab facilities for their work.
It's and it is difficult to find the financial support from the government to do research for
very difficult. Very difficult.
Very difficult.
These days, more of our research funding is coming from private companies, or more often from overseas. It's very difficult to get research money from the government these days.
Yeah. I see a lot of good facilities in university in Sydney here. There are a lot of very large machines, expensive, something like that.
Yes.
Compared to my country, it's difficult to afford this machine for students.
Yes. Well, a lot of this.
Did it from government, the whole from?
Yes, but it's been built up over many years. But this particular rig, for example, this engine, this gearbox, and many of these parts here were given to us by companies who wanted us to work with them on research. So our faculty, we designed and built all the frames down below, all of the support systems, the cooling, electric exhaust. We install those. So it's it's a joint in terms of supplying the hardware. It's a joint thing. Partly us, partly an outside company.
And why the company, they have a good people, they have money, and they have everything. Why they want to join with the university?
Well, for some projects, either they don't have the staff or the resources, they don't have the time to do it, or the staff doesn't have the skill, or maybe the company doesn't have the facilities to do the testing they want to do. Often, usually with large companies, large automotive companies, they do have those facilities. But sometimes, like with this particular project, they didn't have those particular facilities or the in-house expertise on their staff. So we work together with them. But for the smaller companies, often they have no testing or research facilities at all, and then we work with them. This is a student project where the student is working on an electric motorbike.
Electric motorbike.
Yeah, he's replaced the petrol motor with an electric motor and a set of batteries.
Yeah. What is the result? It is comparable. It's better than the gasoline engine.
I don't know. It only started recently, so it's still under construction, still being built. I'll show you a better car now. Our students designed and built this car. You probably heard of the Formula SAE competition.
Competition. Yeah. I saw this similar thing at University of Sydney.
Yes.
And there is a competition here and
worldwide.
It's worldwide.
Yeah.
And then and how the fund to what about the finance? Student they pay for themselves or university?
No, the university pays for most of it. We get some sponsorship from companies.
From company.
Usually they'll supply parts. Occasionally they'll supply cash, but usually it's equipment and parts.
Yeah. This is gasoline, and the competition is like a normal race car. Who can go faster? The first one who win.
Yes, there are different categories. The students it works on the basis of points. And students get points for various design aspects of the car as well as performance, as well as the performance. Yes, certainly speed, time around a track is a big part of it, but it's not the only part.
This is undergraduate or
Undergraduate, yes.
undergraduate level. Oh, undergraduate.
There is. So most cars are petrol powered, but there's now also a category, I think, with electric powered cars as well, which we might be getting into later on. We don't do it at the moment. So there's another category for electric race cars in the same event.
And what how many years so far for that competition?
How many years has it been running?
Yeah.
Oh, more than 10 years.
More than 10 years, and who always win in the competition?
Well,
Which,
nobody always wins. Each year, different cars will win because it's not just a question of having the fastest car on the day. It's also got to be reliable and perform well on that day.
Yeah. And this car, it went to the competition already.
Yes, last year.
Last year. And what was the result?
And the students now building up for this year. Last year, I think we got about fifth out of 20 or so. So not first, but we're starting to get closer to first. We're getting more competitive.
Yeah.
Some years we do well, some years we do bad. Generally speaking, I think each year we do a little bit better than last year. But sometimes we might just have bad luck. Maybe there's some problem with the wiring, which really either stops the car completely or it degrades its performance. And other teams have the same problems as well. So it's both good design, hard work, and a bit of luck on the day. In this laboratory here, this is our manufacturing laboratory where students learn how things are made.
I know. I used to study all kind of these machines.
Oh, okay, right, yeah. So the students maybe take something apart and they look at each individual part and they say, they examine how it's made, what processes are involved in making that part.
And there is one CNC machine.
We use it for teaching, for classes. We have other CNC machines behind that.
I saw the other one at University of Sydney, and it is very big. It's 8 million, a lot bigger, and that one can be it can be used in. I mean, the program from computer to order.
The machine like that is quite normal program. So that's a CNC lathe, and behind the wall there's CNC mills. Part that can be turned on that lathe, bring their program down here. We may do a dry run on some soft plastic or something like that, make sure the program's okay. If that looks okay, then we'll put the steel into the materials into the lathe, and the final product will make No, it's not a CMM. It's not a coordinate measuring machine. Just a mill. Just a mill. Yeah. So again, the students learn how robots are used to place things as part of the manufacturing process. Let's see here. So we do that. The students are given a task where the robot has to pick the disc up, put it in different places. Maybe there may be some color recognition where the computer does something with a red disc, but does something different with the blue disc.
Yeah. What program they use?
I don't know.
It's the,
Software, I don't know. It's not my area.
uh-huh.
But it was. A competition where the students are given a basic small mobile device,
Oh,
like a
yeah,
small robot,
small
and
robot.
they have to program it, put sensors on and program it to find its way.
Oh, you to walk
the
around.
course.
Yeah.